Hello everyone, this is Karthik from CSCI studying in Sri Venkateshwara College of Engineering, and now today we are going to discuss about geothermal energy. Uh, Basically, geothermal energy is the energy which lies embedded in the earth crust, and in other words, heat energy stored deep inside the earth crust. The examples of geothermal energy are volcanoes, geysers, hot springs, boiling mud pots. These are the major examples of geothermal energy. Most geothermal energies produces low grade heat. I mean, the temperature of most geothermal energy is 50 to 70 degrees Celsius, but rarely geothermal heat is available at the temperature of 90 degrees Celsius, and these are processed by turbines. Geothermal power generation is a method of producing electricity using the earth's natural heat. There are two ways of producing the geothermal energy. The first way is heat energy is transferred to a working fluid which operates to the power cycle. This may be particularly useful at the place of fresh volcanic activity, where the molten interior mass of the earth vents to the surface through the fissures substantially at high temperature, such as between 450 degrees Celsius to 550 degrees Celsius, can be found. By embedding coil of pipes and sending water through them can be raised. And hot geothermal water, and the second way of producing the geothermal energy is hot geothermal water or steam is used to operate the turbines directly from the well. Head of the steam is transmitted by the pipelines up to 1 m in dia or distance up to 3 km to the power station. Water separators are usually required to separate the moisture and solid particles from the steam. Geothermal plants, at a geothermal power plant, wells are drilled 1 or 2 miles deep into the earth to pump steam or hot water to the surface. These are the two major ways to produce the geothermal energy, and there are some other ways to produce the geothermal energy so far. Uh, the other minor ways of producing the geothermal energy are hot water is pumped from the deep underground through a well under high pressure. This is one more technique, and the other one is when the instead of saying these as techniques, we can call these as steps. The first step is hot water is pumped up from the deep underground through a well under high pressure. When the water reaches the surface, the pressure is dropped, which causes the water to turn into steam. The steam spins the turbine, which is connected to the generator that produces the electricity. At first, hot water is pumped deep underground through a well under high pressure. The hot water is pumped from the deep underground with high pressure. When the water reaches the surface, the pressure is dropped. When the water from the underground reaches the surface, the pressure is dropped completely, which causes the water to turn into steam. That means when the water reaches the surface, the water turns into the steam, and the steam spins the turbine, and the turbine is connected to the generator. This is all interlinked process. The steam which is converted from the hot water spins the turbine, and the turbine is connected to the generator that produces electricity. You know one thing, mainly geothermal energy is used to produce the electricity. This is the main use of geothermal energy. The steam cools off in cooling tower and condenses back to water. The steam which is converted from water is again cooled back, and that condenses back to the water. Here, the diagram of this, the process of geothermal power plant is given. It's a sketch of geothermal power plant, and there is a generator over here, and a steam turbine, steam separator, condenser, cooling water, condensate, steam wells. These are the apparatus involved in the geothermal energy process. You see, the water is digged from the deep underground with high pressure. So with high pressure, when it is digged, after that the water is converted into the steam when it is reached to the surface. After that, the water, the steam spins the turbine, and the turbine rotates the generator, which therefore results in production of the electricity. This is the neat sketch of geothermal power plant. This is also called as wet steam. The major advantages are given below. It is a reliable energy source. It is available 24 hours a day. It is available 24 hours a day. There is no intervention in this. It is available in independent of weather, whatever it may be the weather. It may be cool, it may be hot, it may be whatever, irrespective of the weather conditions. It is available. It has an inherent storage feature, so no extra storage facility is required. Geothermal power plants require little land area. Geothermal energy is a renewable and sustainable. Geothermal energy is renewable and sustainable source of energy as it is generated from the Earth's natural heat that is constantly being replenished. It is renewable and sustainable. Why? Because it is produced from the Earth's natural heat. So that's why it's renewable and sustainable. Low emissions. Geothermal power plants produce very low emissions of greenhouse gases compared to fossil fuel power plants, making it an environmentally friendly energy source. You see, when we want to produce electricity from the fossil fuels, it produces lot of greenhouse gases. To avoid to avoid this, we use this geothermal power plant to produce the electricity without emitting lot of greenhouse gases into the environment. This is environmentally friendly. High efficiency. Geothermal power plants are high efficient with a capacity factor of 90%, which means they can produce power continuously. You see, geothermal power plants are very efficient in producing the electricity. They can produce up to 90% of the electricity. They can work 24 hours a day. There's no problem in that. So these are very high efficient, constant and reliable. Unlike solar and wind power, geothermal energy is a constant and reliable as it is not dependent on the weather conditions. This is already discussed above. So irrespective of the weather, these geothermal power plants works 24 hours a day, irrespective of the weather. Multiple applications. Geothermal energy can be used as a various applications such as heating and cooling buildings, industrial processes, and agriculture. The applications of the geothermal energy is used in various applications. Some of them are geothermal energy can be used for various applications. Some of them are such as heating and cooling buildings. This is mainly used for heating and cooling buildings, industrial processes, and agriculture. You see, there are also some disadvantages of geothermal energy given below. Let's go through this. Generally, energy is available as a low grade heat. Continuous extraction of heated groundwater may lead to subsidence. This is the major disadvantage of geothermal energy. Drilling operation leads to noise pollution. Thermal energy cannot be distributed easily over long distances. Corrosive and abrasive geothermal fluid reduces the life of plants. Some of the applications also given below. Direct heat use. uh, there are mainly four applications given below. The first application is electricity generation. Energy is mainly used to produce the electricity. That's the main application of geothermal energy. And the second one is heating and cooling. So geothermal energy is also used to heat and cool the buildings. This is the second application of geothermal energy. And third one is industrial process. Geothermal energy can be used in industrial processes such as food processing, desalination, and mineral extraction. And the fourth one is agriculture. Geothermal energy can be used for greenhouse heating, crop dyeing, and aquaculture. Aquaculture, uh, it's like growing something in sea or water. So this is also used in agriculture. Thank you.